session on weatherstripping with Sill. Hi, so we're doing another TREA how-to workshop. So my name is Fatima and we're doing a session on weatherstripping with Sill. So welcome.
Hi. So we're going to look at the general simple things that you do to prepare a house for winter, but weatherproofing is basically a way of controlling the flow of air between the outdoors and the indoors. We can seek to control it just between indoor spaces, but primarily today we're looking at outdoor. The first thing that I want to do is I want to get down to how we might be choosing weather stripping, and then I want to look at different techniques that we use at doorways and windows. We'll also be looking in part at electrical outlets, which can be simply done with this type of sealing. And many houses don't do this yet. The general simple things that you do to prepare a house for winter, but weatherproofing is basically a way of controlling the flow of air between the outdoors and the indoors. We can seek to control it just between indoor spaces, but primarily today we're looking at outdoor. The first thing that I want to do is I want to get down to how we might be choosing weather stripping, and then I want to look at different techniques that we use at doorways and windows. We'll also be looking in part at electrical outlets, which can be simply done with this type of sealing. And many houses don't do this yet. The thing is that I want to get on about is there's some principles for air sealing. What we need to be aware of is that the air is coming this way and that you want to stop it because you want it to stop going in here. So you put a membrane here. Often it's compressible, so you would close a door or a window against it and it would push down to here, and then the air can't get through. So many of the items that we're dealing with are going to be compressible. Most of them are plastic. In some cases, we'll be looking at natural ones. This is a natural weather stripping device. It's removable caulking, and they've been using it since the 1850s on windows. It's covered with a bit of wax. You push it into the gaps in the windows for stopping winter movement of air. You then pull it out in the spring. And then there is this typical type of weather stripping, which you can buy in different formats, often lengths. And this is often used in doors and windows. You can also see this stuff's used in your car if you look at all the junctions where the doors close. So there are many different types of sealants. You can check the shape of a seal by looking at the back. So this one is multiple serrated ridges, which if combined will stop with the pressure of air. With other ones, you'll just find just one single item that will be just representing one. But it's up to you where you want to decide to use these things. This one is for the bottom of windows. So we'll be looking at this one later on. You unroll it and you put it on the bottom of a window. So with air sealing, if we draw a door, we have three typical areas. We're doing the top, okay? Now the top is often using the same piece that is on the sides. So you just have to work out how you're going to apply it. On the bottom, you have the wearing of feet. So often it can be worn out. A typical one that we will see is a metal plate and a rubber top, and then that presses against the door so that air doesn't go through it. And that can wear out. So we're going to look at this technique of doing doors, two types of doors, in a couple of minutes. Windows don't have people walking through, but with sash windows, we have the window coming down, and we generally put a weather strip here. Often the frames go out of balance and the air gets through. We'll also look at the sides, and there's a technique here. So again, you get this zone where you're using the same material on certain sides, and then where there's a wear point, you're using a different type of material. And so when you go out to get weather stripping for either doors or windows, you're buying two types of weather strips. You can't use the same throughout the whole way. We're going to look at a special type of door system. One of the most common problems that happens with doors is the threshold is flat. It doesn't have any profile to capture weather stripping. So what we're going to be looking at in a while is a special type of weather seal that when it's pushed, the weather seal comes down onto the gap so that that gap now doesn't have any wind going through. This is all your wind coming this way, and so you don't have it. But when it's up, the wind can go through. So that's a standard sort of detail that you can put into doors, but it requires planning. But it's a very common detail to find in old houses where we just have flat doors. The other issue, and I'm going to show it later on, is that sometimes with foot traffic going through, the threshold wears out because the feet wear out the stone. So in this house, which is just over 100 years old, the stone has shaped. It's taken the foot traffic. So now you have a permanent air gap going through. So I'm going to show how we deal with that. So we have air moving through a house. This is a house. And the action of air coming into a house is guided by the strength of what we call the stack effect. If you're a one-story house, the stack effect isn't very high. But the higher the house gets, the stack effect increases. The stack effect is the suction of air that comes into a house. And so what we're trying to do is we're trying to limit the flow of air into the house so that we don't have this stack effect. This is a tremendous importance in terms of energy conservation. So if you have a very tall house, you need to address the stack effect, which means you need to also stop the air coming out of the house. So not only are you stopping it coming in, you're stopping it going out. So your air sealing approach or strategy must take on both the entry and the exit. In many cases, people will just focus on the entry of air into a house because most of these products are about air coming into a house. But the big issue is, how do you deal with the air coming out of a house? And often it's the case of large holes. So you may have a hole here. So what happens when people do air sealing is they do manage to seal all these areas where the air is coming into the house, but they don't think about these areas. What happens is they've done an awful lot of work, maybe a week's work of sealing all these holes, but they never got these holes here. And so what happens is that these holes become even more efficient at taking the air out of the house. So when one addresses a strategy of air sealing, you must balance what is coming in and going out. If you unbalance the flow of air, you're going to increase the amount of air that goes out, which means you will lose a lot of warm air inside your house. This is another common problem with houses. I'm looking north at the moment, And so we have the northern winds coming in, which are often very cold. And we took down an extension here which stopped the house seeing the back garden. But what we have is a doorway, the original doorway of the house here, which was coming into an internal space. And for years, it was always a cold door because the brunt of the wind is hitting it. And so we built a draft lobby. A draft lobby is a technique of controlling the pressure of wind on a door from the outside. It's not sealing. What it is it's creating a room, a draft room. And so what we did is we put one of these standard sort of ubiquitous aluminum doors just to take the brunt of the wind, and then we do the air sealing on the inside, because it can be quite brutal in the winter with all the northern winds on this door. And so this door allows the vision out into the garden, but we'll be focusing on this one here. However, it is worth noting that these doors also can be sealed. As you can see, we have some seals on them. But the problem with these doors is the way they're manufactured. The windows themselves, they're single glazed, and often you're having them open with screens, and they loose fit, so they're going to be leaking. So you can't use these as effective leak-proof doors. You're going to have to invest in a much stronger door if you want to do that. But this is a draft lobby, so it's just taking the pressure of the air from the outside wind, and it's just modifying it so that we can do more gentle detailing of the inside door. So the point is that there's a piece here that is supposed to be, do you see this piece here? Yeah. See how it comes out? It rests down when the door is open, or when the door is closed. And then when the door is closed, it's going to be pressed down, and it's going to seal the gap. This is a special detail that you cut into the door. It's not cheap, but it's a very effective way of controlling the air coming in at the bottom. The air can come at the bottom, and so you have to seal all your woodwork on this type of building. So this is a single pane of glass. Again, it's not where we should be with, let's say, deep energy conservation. The other thing is that in many cases, old doors have existing holes, for the locks. We've taken them out. We've put in more modern ones. And so you have to think about all the ways in which air can actually enter into the building. So we're going to be focusing on this area here, and I'm going to open this chap. Now, the thing is when you're buying air sealing, you need to make sure that it's going to be hard wearing. A lot of people buy very cheap sealing, which is just foam that just goes around the house or around the door to the house. This is actually quite hard wearing. You can focus on it when I have it opened, but it's a vinyl outer thing, and then there's a rubber on the inside. So this can take a lot of wear. So when you put this in, it'll probably be here 10 or 20 years, depending on the use. I've taken this one off, but it had vanished in the lower area because the dogs keep coming up to the door, scratching the door, and their nails pull this apart. So you have to try and work out what your maintenance is on some of this type of stuff. If you have dogs, you're probably going to wear out on door seals. You can see all the wear that they've done to the door, so you can imagine how they just ruined all the wood here. So let's open this up, and we'll start, okay? So the issue here is that you can see it's quite a tall piece of, or a long piece of product. And the reason is that it matches the approximate height of a door. So you see here that it's cut just long enough so that this bit would be cut off so that it can fit in here. So we have two of them, one for this side, one for this side, and then there's a short one which goes across the top. As I said to you earlier on when I was doing the drawing, that the bottom piece is always a different detail, and often it has to be hard wearing. So what we're going to do is we're going to measure this and we'll cut it. So I wanted to show you how easy it is to do, so that people understand this.
So this one is 2 meters and 40 millimeters.
Now sometimes you have to leave them a bit short, but you will cut it so that you'll get the foam right down to the bottom.
You want all corners connecting. The reason why I'm showing how we do it is if you look at this detail, you see that the metal extends and we have to stop the foam short so that they can meet with each other. So this is 2 meters and 40 millimeters.
And let me see, I might as well do it in here. So this is just to show that you can do this stuff quite reasonably, and it's not too expensive. The unit, or this particular setup, cost about $50. So what I'm doing here is I'm looking at the dimension, and it's 2 meters 40 millimeters, and I'm noticing that I'm not going to end up with a hole to hold the bottom part. So I'm going to make 2 cuts. I'm going to cut this so that I can get the hole here, because there's a hole. Can you see the hole here? Now, if I use the actual dimension, I'm going to miss the hole. You want to really make sure that the outer edges of these units are always very strongly fixed. So I'm just going to cut this here and then measure after that. Everyone has an old metal saw. I'm going to have them closer to the termination points. You can see I have one down here. So I've cut it so that I'm going to have this matching on the inside like the other way, and this is where we're going to have the item. This is slightly short here, but that's what we're going to be doing. And so they're going to be connecting. And then I'll show you how we go and deal with the installation. So we just have to make this 240. this one is slightly different to the manufacturing of those pieces. On this one, they've glued this together. The other one, you could move the top. So you have to leave this a bit loose in case you need an extra length. So just cut the metal to the length you need. So what I've done is I've cut the hole, or I've made the cut to this point. I just have to get a tiny bit more done. I'm trying to leave this piece longer, okay, so that they can overlap. So we have this. This one goes up here, like this. We can connect them. And this one, I have just enough. And okay. So about 4 millimeters. Sometimes you have to make it a tiny bit longer so you can take the slope of the threshold. So there we are. And this fits right against the ground. And this is fitting in here. So it's a fairly easy application. Now, without trying to get too complex, what we generally do is we use a glue, a thing of draft attack. You can use many different ones. This is a removable Weatherstrip caulking, but you can also get a permanent one. And we need to take this out and but there's a nozzle, there's a piece of plastic here, and you don't cut it down here because there's too much coming out. You just want a gentle bead, and do it so that you can get quite a number of windows done. So I'll just cut this here. So we've cut it on an angle, because you're going to be doing it, and it's a gentle bead. So what we will do is we then have this item here. This is in case people haven't used this type of stuff before. And this is for making a hole in the seal. You see, it's just longer. So you just go and create a whole load of little holes. Maybe one hole is enough. Put that back. This actually so happens to be quite a good gun. Quite a lot of contractors have used it, and they've said that it's quite good for its expense. And you can see now that the stuff is coming through. Do you see that? So what we'll do is if you come up and get a detail here, we are going to put a permanent thing of caulking all the way down here so that we don't get any air going underneath the ceiling, okay? Because otherwise we're defeating the whole purpose of the seal. These are where the screws go, and this will put the sealant on here. There are many different types of silicons you can use. Sometimes it's actually good to have them as removables. This is actually a removable one. Put it down on the edge so you can get it done We're going to be screwing the seal to the door frame, so there'll be a lot of pressure put against this bead of sealant material. But you can see that actually it's really quite inexpensive. We have a sort of a plug and play approach with these type of tools now. So you don't have to be going out and making arrangements with special companies to get this done. It's something that you can do. And if you buy very good stuff, it'll probably last the best part of 20 years. It's a pity it would have to be replaced. If you take better care of it, maybe it could last up to 50 years. But they tend to have a lot of plastic in them. But this will really limit the access of air at this door. Now, I just didn't prepare this enough this morning, but normally you would repaint the door, which is something I'll have to do. That's why I'm using the reusable one, because I'm getting it in, but I'm going to have to take the seal off when I start to paint the door. So that was the reason why I was using the removable caulking. Make sure you're always sealing this stuff so it's not drying out. So we now have it in place. We have the seal that we want to put in. Now, just to remind you of silly things that happen, you could put the thing in this way, okay? But it's incorrect. It's not facing the door that's going to close, so it's not going to hit the seal. And you've got to make sure that it is. So once you have it started, it's an easy process to know what to do. But make sure you get the seal in the right way, otherwise you're going to have to take everything out. We have this sealant underneath the thing. Often you're not told to do this, but it makes sense to do it. And now we're going to put this in. There we are. So just put the thing in. As I said, cut the foam a bit longer so you can make sure it's touching the very bottom. Get the thing aligned. And then just do a test run. Check with the door. And if you have a pen, close the door. The reason you do that is to make sure that the door is closed tightly against the item. And then, nowadays, they're getting very sophisticated with the way that they give you the screws. So I'll just cut this. Now, the other thing to notice here, if you zoom in, you'll notice that it's a lung hole, so that you have play. You can maneuver the thing properly into space so that you can then put the screw in. Now, the screw is going to pressurize the sealant that we have underneath. So now you're not going to get any air under this. This one is different from here, and it's been glued, so there's going to be no air getting through here either. So I'll do the other ones later, but you just have to align with the line that you made. What's happening here is that the sealant, acoustic sealant that I used, is actually holding this in place. But you don't need big power tools. I've tried to take a very simple approach to this, because the simpler it is, the more likely one is going to put these things in, rather than living without these points of air leakage. So there's about 12 of them that we have to do. This is up here, this will be connecting here. You might want to come out here. And then watch the door closes against it. But you see how it's pushing? You see how it's pushing? You might want to come out quite close. You see how it's pushing it? So you want that to be pressured. And now we've got this where all the dogs were scratching and they'd removed all of it. Now we got a new one in. So that's good. Again, one would try and putting caulking in all of these gaps. That's what it's all been planned for. Let me just show you what happens with these windows. The windows have leakages everywhere. Just a typical window, it has to have slack. It has to be able to move. But you know, if you have a winter wind, that's going to really tell you that there's something happening outside. So you want to control the air, because that rocking is actually pressuring and pulsing with the wind, and it's bringing it all in. So you want to have it tight, and you want to have it fitting against all the edges so that you reduce the air coming in. The other thing is, if you come up here, you'll see that we're looking at trying to get this side here, because you see how the window moves here? I'm sorry. See how it moves? We're playing with about 2 millimeters of gap there, maybe 3, and that 3 millimeters would be 1/8 of an inch. And what we need to do is put a sealant down here. We can put one here, but as I've said, anywhere where there's a passage with gravity, it often gets worn out because people are walking on it or passing things. And then we have to look at where this gap here is. Here it is here. I don't know whether your filming is going to pick it up, but you get this back bit of window here, and you want to stop the air coming in there. You see how much it moves. Now, there are all sorts of other things that we have to do, but it's important in summer that you can get cross flow, because then you don't have to use air conditioning, particularly if you're taking the air in from areas where there's shadows. So the other big area where we have the flow of air is down at the bottom. You see how it kind of jumps? Now, you can get gaps. They can be like that. And so you've got to put something in here to stop it. Now, we did have this window. It was all painted in, and we loosened it. And when we took the paper out of the top, it was from 1953. And it was all the historical things that had happened on that day. So we have this gap here, and what we want to do is we want to cut a piece of sealant to put here, but I'm going to show you first of all, I'm using a piece of cardboard because it's much easier than actually looking at the piece of plastic. Very difficult to find. Can't get it at Home Depot, can't get it at Lowe's, but I found it at Home Hardware. And that is, it's a very simple piece of plastic, and it gets bent in a V shape. And this gets put in, it's got a piece of tape here, sticky tape, and you stick it onto your window. So what you would do is you would put it in against this side here. I've made this bigger because the piece of plastic is just so small and the V so difficult to sort of control that this piece of cardboard will show that what we do is we put it against here. And if you focus in here, you'll see that, you see it's pointing out. So it wants to rest at that width. So that means as the air comes in, the air is not going to go against the piece that's stuck, and this piece, this opening piece, will rest against the window. So if you put it in properly, you can then close the window. So you need to, that's why I'm saying these are very small pieces. So what I'll do is I'll just show you. If it goes into the window, this is what you're going to get. And it's going to stop the air. It's projecting at the moment. You can get different heights, but I'm just doing this just to show you. And it will stop the air coming in, particularly if that's glued and it's pressurizing against that. And you can even see that it's actually stopped the window already moving, okay? So I'm not saying that that's a test, but it just so happens to happen. Now, I want to show you what we do with the bottom of the window. That this detail, this thing, runs around here as well. Now it's a very thin piece of plastic. It's very difficult to see, and you can easily put it in incorrectly. But it goes here, okay? And you can see that on windows, there are different heights for all of these pieces. So you won't see it, but it will definitely hold the wind off. Very good and very inexpensive. They're about, I don't know, $3 or something to get enough to do maybe 2 of these windows. So what we're going to look at now is the bottom of the window. And let me just show you, this is a rubber windowsill. Forget this is just trying to say how great they are. But it is useful to see that it remains flexible at -40, which isn't that cold actually. But the thing is it's useful to have. We have how it's made. It's got a self-adhesive, which means it sticks, unlike what we just put in at the door. And it seals doors as well as windows. So if we just look at this, open it again. That is if people haven't already opened them in the store you buy. This one was got from Home Depot, but you can get it from Lowe's and the Home Hardware. And let me just cut a piece just to show you. Before we put it in. So, what we're looking at here is a piece of plastic that has a piece of grease or waxed paper, and then you've got your sellotape, double sticky, and there's what it looks like. It's pretty much what the drawing looks like. And what happens is, when we put this on, it's going to pressurize against the thing and it's going to close. So if we were to do this, we use this bit, we were to put it here, like in the thing here, we could see this closing down, okay? So that is another way of trying to address the air that comes in at the bottom of a window. And it's what they call a draft and weather sealant. It's made of a sort of a cotton twine, and it's soaked in wax or in paraffin wax. So this one here it stops drafts, window rattles, and moisture damage to seals and floors. It's non-drying, flexible polymer sealant, and it will not adhere to hands or clothing. No cleanup of surface is necessary. For the most part, that's pretty true. You can see its color. It's actually white. Here it is here. and it comes and it looks like a piece of wool really, and it's quite flexible because of what it's made from, and you just push it. So this is an old piece. This is about, I don't know, 15 years old, but it picks up all the dust. So eventually you've either got to clean them or you get some new stuff. But the useful thing is that you can, on a warm day, not on a cold day, you can put this in here and you just wedge it in to the holes. You see how I'm doing it? This is a very inexpensive way, and really I think quite a sustainable way of dealing with technology and the constant issues of things like air coming into houses. You do this to all the sides between the things here, and that will last all winter. You won't get anything going through. I think it's actually a pretty neat idea, this one. And it's better than using the caulking gun, which you can use. That's what this particular one for. It's called Draft Attack. And you just put it across here. And then in the spring, you can pull it off. But this is a more, I think, sustainable way. But you can see it gets dirty and everything. So the grunge of sustainability. Now, what else have we got? Yeah, I just wanted to say that we have the issue of the window, okay? So this is a standard window thing. I don't know whether people have used them. In many cases, we go and use them when we don't want to get double glazing. And it's particularly so if you have north-facing windows, and if the air is constantly coming through, this will fill up like a balloon. So you really want to control the air coming into this space first before you do anything. I won't put it up, but I just wanted to open the box and show you what you have. Inside the box, you get obviously a guide, and you get double sealant tape. And what you do is you'll run the tape. In this case, you'll probably run it on the outside, but you could run it in here. So this is just ordinary paint tape, but this is the double sealing that we would use. Normally you'll put this on, you'll put the roll, and it'll roll down. But just so you can see it, you take a bit, and you're going to put it in against here. Sorry you can't see it. There. Make sure it's properly tightened. Then you peel off the white waxy paper and you're left with a double-sided thing. And then you unfold this and you will take this and you'll make it larger than the opening. You'll maybe give it that much, because there are two reasons. You mightn't put it on straight. So if it's on a bit of an angle, you want to make sure that you get everything. Like everyone seems to think we put them in perfectly, but we never seem to. So you put it down, plenty of stuff here to take on the accidents and misalignments that you do. And then you just rub it on. Again, try not to do it on a cold night, because the glues won't work though. And then when you're finished, you go and use a hairdryer and you just heat it on the thing. Don't heat on one spot, because you'll burn out the plastic. You see how thin this plastic is. So too much hot air on this will actually create a hole. So you go very gently over the plastic and you keep going down, allowing that to cool, and then you come back down again. And as you heat the plastic, it contracts and therefore it gets tight. But you have to make sure that that overlaps everywhere, that you don't have any little air gaps. Because once there's an air gap and the wind can get through, you can start opening it and then you've got a flapping thing. So this is important, particularly if you can't afford double glazed windows and you're sitting beside a window that is just cold in the winter. You know, often if there are windows that overlook TV areas, etc., and people have the air coming down the back of their necks. So that's enough on this. I want to show you, I'm showing you this one. Now, you can get different sealants for windows and doors. This is another one. They call it closed cell. That means that it's slightly dense. Slightly. I don't find these particularly good for a lot of heavy use. But they are okay on some of the rare doors that you can have. You might want to just zoom in. Can you pick that up? Is it okay? And you can see it showing a, I think it's a window. So it's for a small gap, it's self-adhesive, and it's got minimal compression, okay, for a tight seal. That doesn't look like minimal, but that's how they sell it. There are much harder ones. Then there's this type, and this can be very effective for doors that have gone out of whack. So we didn't need to use it here, because this is going to hold everything, okay? I'm just checking. But you could use this, but I find it's too flexible. There's too much flexibility in it, and you're going to have to tighten it. So I'm going to show what we're going to do with a door where this problem exists. Notice here, though, that they've filled it. They put a foam inside it. Quite often you can't buy it with the foam, and having the bit of foam makes it much more robust. That door is closed. Do you see the light coming in at the bottom? Now there are very few houses that would have this problem, okay? Yeah, of course it's an old house, it's not because of it. But the door was perfectly made. I made the door, even though the house is settling. It hasn't settled that much. What's happening there is these are double doors. Sometimes they used to be a door and a half door. The half door was called a coffin door because you had to carry the coffin out of the house, and often one door wouldn't create the space for getting the coffin out. Double doors, again, they're sort of more ceremonial for carrying out a coffin, but very useful for carrying big objects through. The problem is with these type of doors is draft proofing them. So I'm going to show you how we can do that. So the reason why we have this gap here is if you see on this side here, it's nearly reaching the bottom of the door. Here it's maximum. If you go back, you'll see the gap. The reason is the foot traffic has worn out the wood, or worn out the stone. So over 100 years, or 115 years, the stone has literally worn out. A common problem with old houses. We see that we have this detail down here that I've rebaited in the bottom, a draft thing, and we have a little small thing here that when we push it, you can hear it working. So when it closes, it should be resting against something. But very often what happens is these things wear out the wood. So you need to put in a small screw here to maintain the pressure point. But this is very well worth it. But, you know, most people aren't going to go to the effort of taking the door off and rebaiting it. Here's the closed door. And you can see that I have a gap running around here, okay? It wasn't until I was asked to do some weather sealing that I actually got about to put the weather sealing in. It's been like this for 15 years. But the detail was planned 15 years ago. Now, I could use the same type of sealant that we used in the back door. Here we are here. And I could put it here, okay? I could put it in there, and then we would see quite a neat thing happening here. But because this is a heritage house, it's a bit unsightly. So we didn't want to do that. Again, we have to run it on the top so it becomes quite visible if you have it up here and there. So we wanted to keep the idea of wood, mostly. So what we've done is we've rebaited And that is, we've cut a little hole all along to receive what is a very hard-wearing weather seal. This should last the life of the door. I would say that it could probably last up to 100 years because of the way it's made. So we then inserted that into the door, and then when we close the door, we get it resting against. But again, we have this whole issue of houses moving. We're playing on very small movements here. If they're anything larger, then you'll get air gaps. So what we want to do is, I took a double defense. I decided that I would put something in here. So I've sorted that out for you. And what we're doing is, we have this piece. Now, this is actually, I don't know where I put it. Do you need to see the big thing of it? The thing is that this is similar, but this is what you use for a car. If your car door is leaking, you can buy them for car doors. And what I've done is, it fits in here. Can you focus in on that? Here. So when the door closes, it's going to close against it. But this isn't wide enough. So let me just show you. Any of the plastic receptacles, but all of these things are built with a little plastic cup, and they sit into it so that the air isn't coming through. But a common issue is that when you have an existing house, you have air coming out of this, and again, you're losing energy. So what we can do is we can put this little seal here, and it's going to cover over the hole, and then we can then screw this into the original thing. We have the screws here. Whenever you take these off, always make sure that you've kept them. And we just put this here, and then we can just screw this in here. And then that stops the air coming through. It's a gentle technique. And it's inexpensive, but really the receptacles and these boxes should be in the plastic containers that hold it and stop the wires going through, because there is going to be a lot of air in these walls. And you have to look at all the areas where the air is coming in, okay? The air actually also comes in through the sewers. And so we have air coming in, and then we have air coming out. So this could be a project that could take several years, maybe 3 years, to actually spend maybe a week each year on maybe a couple of small projects to seal the air. And so we look at the windows, we look at the doors, and we look at the things that are up in our roof to try and stop air getting through there. We also have the internal walls where air comes in and goes out into the attic. So we have to stop the air on the inside walls and on the outside walls. So everywhere where you have all of this issue of air moving through the structure, we have to capture. What we've done today is we've looked at doors that face the north, and we've looked at how you would replace the seals on the 3 sides of a door, and then we've looked at a movable seal on the threshold. The other example we looked at was the front door, which was double doors, and we've looked at trying to put in a special plate there where we pressure plate there, and we've looked at how you do the 3 sides. Then we've looked at the windows, and they were sash windows, which go up and down, and we've looked at sealing on all sides, and we've looked at a special seal that then moves down against the sill of the window frame. We've looked at the electrical outlets and how we can get a foam piece that goes around the electrical outlet, and then you put the finish cover on it, and that can stop air as well. And we've looked at the acoustic ceilings, or the air sealants that you can use in group, and you've seen also the use of the sustainable cord caulking. So that's about it on sealing.
Well, thank you, Shane, for joining us and telling us about weatherstripping today. It was really wonderful to hear about it.